Here it is. I will probably stop my video now in order not to disturb you. And so today's mission that I have is to present the Connecting Europe Facility automated translation platform. However, I only have half an hour, so I will mostly focus on e-translation. The CEF-AT platform includes much more than just a translation system. It also includes named entity recognition system, and as an example, I could mention the multilingual tweet. You can send Twitter messages in all European languages and even more, even other languages can be included. Just a tool offered on the CEF automated translation platform. So today I will present to you e-translation system. Okay, and here it is. Here's our short plan for today, for this half an hour. First of all, I'll discuss human limitations and understanding languages. The second point will be about CEF e-translation itself, how it functions and how it can assist us humans, the limited humans. And the third part will be about neural translation, neural networks, and how the automatic translation works in general for those people who are not related to language technologies at all. At the end of this presentation, you will find any necessary information about how to register to the e-translation system. Yes, to register, because you need to register, unlike to other online translation systems. The registration is available for universities, for public administrations, also to small and medium-sized enterprises, freelance translators as well. So we have a broad audience that we accept as clients, but you need to register, and you will find all the information at the end of this presentation. So let's start with the controversial question. What are the limits of us humans in understanding languages? And such human beings are called hyperpolyglots, the ones who know a lot of languages, as you know. And how they are defined, Michael Erhardt, author of the book Babel No More, says that it's a person who speaks more than 11 languages. So you have to know 12 languages in order to be called a hyperpolyglot. And some examples could be the one from the history is Italian Cardinal Giuseppe Mezzofanti, the cardinal of the 19th century. He spoke 30 languages. It was evidenced that he really spoke those languages, and he studied another 42 languages. So it's a very famous example taken from Wikipedia. And from today's world, I could mention a teacher, Derek Herning from the Shetlands, who spoke 22 languages. It's also an evidenced fact. He won European polyglots competition. He passed away just recently. And the one example of a living polyglot is Ioannis Economou. He is my colleague from European Commission. He's a translator and he speaks 32 languages. And unfortunately, I have to mention that such examples are very rare. A hyperpolyglot is always a language professional of some kind. It's a translator, interpreter, linguist, journalist, spiritual leader, maybe actor. For example, here we see a picture of the Pope Francis. He speaks 7 languages. If you're interested, it's English, German, Spanish, Italian, Latin, Portuguese, and French. So they are rare. And what about the rest of the population, about the common people? Actually, to be considered having a good command in languages at all, in general, you have to know at least 2 foreign languages or more. So what's the share of such speakers in the population? You can see here the statistics for the upper secondary education pupils. In the European Union, the share of such good speakers is 48%. You see a large variation in the European countries. Finland is not among the worst speakers, as you can see. It's actually in the top, among the top speakers. In the bottom, you see Greece, Portugal, Spain, and Denmark. But what I wanted to say about this phenomenon of good and bad speakers is that there are lots of people in the population who speak only one foreign language or no languages at all. And these dark green columns show exactly this share of the population. So those people really need assistance from machines, maybe. And I wouldn't say that such people are lazy or incapable of learning languages. Maybe we just don't invest in their time in languages. They may be not interested. They may be interested in mathematics and so on. For example, US presidents, Barack Obama and Donald Trump, they are monolingual. Maybe Barack Obama knows some Indonesian, but that's about it. And they don't see a big problem in that, maybe. So the real polyglots of our days are, in fact, machines, robots. When did it happen? Actually, it happened in 2006, maybe, when Google started offering the automated translation service. Or maybe later, a little bit later, maybe, then they increased their offer of languages. But in general, now we can see that the selection of translated languages is in fact impressive. Just look at the selection of some popular services that I've picked, and they've counted the languages that they are offering. E-translation is one of them, and what's so special about e-translation is that it's a European service, actually. It's a European service. The dominant services are, of course, the US services. China has some strong competitors, but in fact, and by the way, those selected services, they all offer Finnish language as one of the languages. And what's so special about e-translation is, as I said, it's a European service. And what does it mean for us? It's actually, first of all, the security of data. I would mention this important aspect. Also, the security of intellectual property. And also, the data that we're using is largely based on European legal environment. So it's also important when we speak about translation of legal documents, official formal documents. Here is this aspect of security of data. You can see this aspect here. E-translation security plan is accepted by the European institutions, all European institutions. Even, for example, European Central Bank accepts our security plan. So it's important to know that not all documents are suitable for e-translation system. Sensitive non-classified security class documents are acceptable. It's very important. You wouldn't translate such documents maybe with some other commercial providers. However, we are saying that EU restricted or higher security class documents are not accepted. So that's important to note. And the history of machine translation at the European Commission is really very rich. We started everything almost 50 years ago. It was firstly a rule-based system. Then in 2013, just recently, we've introduced actually a broad statistical translation system for all EU languages. But it's all history. It's all history because, as Karina Hyvönen mentioned, I think there was a large paradigm shift to the neural machine translation systems in around 2017, and we also switched immediately to neural machine translation. We are currently offering not only EU languages, but also Icelandic, Norwegian, and some other exotic languages as our service package. In terms of translation quality, the situation really improved. That's the answer to Philip Ginter, who asked whether Finnish language is really in a complicated place at the moment. And in fact, yes, Finnish is at the very end. It's a kind of negative message, but the positive message about the quality scores would be that they are comparable for all languages. This table indicates the BLEU score that you shouldn't, and this table should be taken with a salt of grain because the BLEU score, it's always about the context. What is important here is to compare languages among themselves. And what I wanted to say is that Spanish language is not much higher than Finnish language. If you look at the scale, Spanish language is the fourth column. It has the BLEU score of 60, maybe 3, and the Finnish language has the score of 47. So the difference is indeed very small when you think about the morphological difficulty, complexity of Finnish language. Then it's really impressive that the difference in BLEU scores is very low. Let's go to the practical side. When you log into your web interface, it looks like that. It's familiar, typical interface, comparable to any online provider. What is different here is the possibility to select a domain. Domain means basically the data set from which the data for translation system is trained. And the selection is the following. You can see the opened list. For Finnish speakers, I would actually recommend 3 engines, 3 domains that we have. It's the first one, EU formal language, and general text translations domain. Those are the star engines that we have. And I would like to mention the last one, Valtioneuvoston kanslia domain. It's the Prime Minister's Office data-based domain, especially for Finnish speakers. So those star domains are EU formal language, which is built using translations of EU documents. It's best used for formal documents and text related to EU policies. And another domain is general text domain. It's built using a wider scope of documents, and it's best used for informal documents and non-EU related texts. Just don't drop it like that, and don't forget that it's really important to select the right domain if you're using our system, because results can be disastrous sometime if you try to translate normal standard conversations using the EU formal language engine, and vice versa. So choose the domain properly. You've been warned. So the second possibility how you can translate is simply dropping the whole document in your web interface in the box. You can drop several documents at a time, and these documents will be translated and sent to you back by email in a couple of minutes, and in several minutes maybe. You can select several languages at once. Several means really a lot, maybe 28 at once if you want. I would mention some languages, some rare languages. First of all, it's Mandarin Chinese. Yes, it's available. Don't be surprised. Also Russian, maybe Finnish. Also translate Russian texts. So Russian is important for you maybe, and I would mention Turkish. Why not Turkish? It's also available here. Just a recent addition. I think it should be already there, yes. And finally, you choose the output format. Usually it's the same format as the original document, and I'd mention that important format, which is TMX format. I'll explain a little about it. So supported formats in a more visual way: Microsoft Office documents, OpenOffice documents, PDF format, HTML, and TMX. This TMX is the most interesting maybe for non-professional language people. What is it? It's an XML format that allows translators, professional translators, to start the translation project. This is an example of a window, of a translator's window, typical window where translators work at the European Commission. They would start the translation project and would see such kind of situation. In the first column, they would see the original segments in the original language, and in the next segment, in the next column, they would see the Finnish draft translation provided by automatic translation. You would probably see some mistakes here, but that's how they start. That's how translators start. And as an evidence, you see the label AT. AT means in the middle column, it means automatic translation. So that's how translators start. And this is the TMX format that is also available in our system. Translations are not only emailed back to users, but they are also stored in the web interface for 24 hours. Later on, they are deleted and forgotten for good. You can also check the status of your documents. If there are any errors, they would be reported here as well. So we always check this table if something goes wrong. One more part of our e-translation system is also a very important API, application programming interface, machine-to-machine system. It's also available to most of our users, but it's a second kind of more privileged service. The client application, say in Helsinki, can send a message to SEF e-translation web service saying that, stating that there is a text to translate, hello world. It provides the languages, source language, target language from English to Finnish, domain, general language, and it says that please send me the result to this email, or maybe to the HTTP destination, or maybe to FTP server. It's also possible. So the message is sent to the e-translation service, and service sends back a reply, hey Maailma, and that's how it works. So use it for your websites, for your applications, for whatever automated solutions you might have. It all starts at the Director General for Translation. Translators generate a massive amount of pages. I just provided the statistics for all languages here. 1.5 million pages in just 9 months in 2020. All the documents are registered in EURAMIS database. Later on, they are reused by e-translation system for training the engines for the automatic translation system. And the product of our system is, of course, reused by translators. 24 million Finnish English language pair sentences are available in the current EURAMIS database. So bilingual data for the Finnish engine is trained on this corpus. So you can imagine how rich is this database. In fact, 24 million sentences. And you can see here an example of some of this, let's say you see 4 segments here only, 4 sentences out of 24 million on the slide. This is a positive note about our translation system. If there is an official translation for a particular concrete sentence, for example, the price of Fela is too high, and the official translation was in French, un échec serait trop coûteux, exactly the same translation is provided usually also in the translation interface. That's a positive thing, because lots of provided translations are in fact official translations, and we have 24 million sentences, so maybe it can be simply reused. A little bit more about data sources. So EURAMIS is the data source number 1, but we use not only EURAMIS database, and we also use other databases. The European Court of Justice has its own special domain designed for them. We also use public health domain, which is trained using the data from those 2 agencies, European Medicines Agency and European Chemicals Agency, by the way, based in Helsinki. As I mentioned, we have Prime Minister's Office engine, specifically trained for Finnish users. And also my regards go to Jörg Tiedemann. Opus project also provides some data for our general translation engine. Now, our third part, I'll briefly discuss the neural translation technology. You've heard a lot about it, and many of you work in the field, so you won't be interested too much. But those people who haven't heard about it will be interested. So, neural translation engine is comparable to a calculator that approximates a very complex function. So we have a kind of translation function. A translated text depends on the source text. It's a kind of function. And a typical neural network, a very simple neural network, looks like that. It consists of neurons. The first layer is input layer, and then we have the output layer at the very end, and in between we have a hidden layer where real things happen. How it works? So we have an input data, let's say 20 bugs and 10 butterflies, depending on the data and on the links, on the strength of links between neurons. Some neurons in the middle get activated in the hidden layer. Then also depending on the strength of links, the output layer provides the answer. So such kind of technology, actually, the hidden layer gets, some neurons get activated, and depending on the activation of neurons, we have a certain answer. So in the case of input layer, different input layer, we have different activations and different outcome. But before the neural network can work nicely to our benefit, we really need to do something. We really need to train it. And the training lasts several days, a week. One engine requires a week of time. And for each domain, 2 separate translation engines for each language have to be trained. Say English-Finnish and Finnish-English. So we have lots of engines to train. One interesting technology that I have to mention is really the method invented by Tomasz Mikolov, Czech computer scientist in 2013, just recently. It's a very recent invention, is this method, word-to-vector. And the idea of this word-to-vector method is that each word in the vocabulary can be represented as a long line of numbers, and these numbers would actually represent the meaning of this word. They would be enough to represent the meaning. Only 300 attributes in each word. We have a long vocabulary starting from A to Zulu, and each word can have a representation in numbers. And this technology allows the numerical comparison of the meaning of words. Similar vector would mean similar meaning. Jörg spoke about universal meaning representation. So this really connects to that idea, universal meaning representation in numbers. So words represented in numbers. We can compare sentences and express their similarity in numbers as well. Here is an example. My wife and I don't often program together, and my spouse doesn't work with me. We program separately. This is a very similar sentence, and it has a high score, and so on. We can even perform mathematical operations with words. Subtracting USA from Obama and adding France, we get Sarkozy. It's a real example from the model. Subtracting Ireland from Dublin and adding France, we get Paris. Such kind of things are enabled by this powerful idea that words can be expressed as vectors. And we can even represent words in a 2-dimensional space, and we can see that similar words cluster together in around the same space. For example, Bosch is close to tools such as drill tool, saw, battery charger, and so on. So words with similar meanings are grouped through context. And the simplest neural translation engine consists usually neural translation engines consist of many neural networks, but this is the simplest neural translation engine, and approximately it would look like that. It would consist of the encoder and decoder, and there is this internal state that represents the meaning. Its internal state would consist of vectors of numbers. So encoder would accept the initial sentence, Thomas lives in Helsinki. It would use this technology of word to vector. Words would be each word would be converted to certain numerical representations. The encoder would encode everything, the meaning of the sentence, to an internal state, and from the internal state, the engine would decode the meaning to the, let's say, Finnish sentence, Thomas asuu Helsingissä. Okay, and of course, there are lots of challenges of machine translation that are unsolved, and one of them is that.
So, dear Vilmantas,
yes?
could you perhaps, if you had something important you wanted to say as a close for people to find this, then maybe that is important to take down.
Okay. So one note is that a human revisor is still needed, and I would like to say that you shouldn't really trust the output of this translation system. And the closing note is that you can use the system by firstly registering on using the following contact information. And for the record, I will leave this slide on, and if you have any questions, you can ask questions. If I still have time, I don't know, maybe not. And that will be the end of my presentation, and kiitos paljon.